All right then, so what I thought I'd do is give a little bit of a chalk and talk, which will help you through these extension questions. So as I go through these extension questions, a lot of what I'm talking about, there'll be some overlap with some of the content which has been covered in the lesson so far. So let's just first of all start off by drawing a energy level diagram for an exothermic reaction. So as we know, we have the progress of reaction on the x-axis, and you've got the amount of energy on the vertical y-axis. And for an exothermic reaction, you'll remember that you start off with your reactants at this amount of energy, and what happens is you have your chemical reaction, and you first of all need to put energy in order to break the bonds between the atoms of the reactants. So as you put energy in, the amount of energy goes up until you get to this point here. And at this point here, all of the bonds have been broken, all the atoms have been broken apart. You remember that you need to put energy in to break bonds. And then you can start making new bonds. New bonds are formed, and as new bonds are formed, energy goes out. Okay, energy is released, and then you end up with your new products. Now, remember, there are various arrows that we can draw on this energy level diagram, and for example, the difference between the amount of energy in the reactants, in the bonds of the reactants, and the peak of the energy level diagram, well, this is the activation energy, isn't it? So that's the amount of activation energy. Okay, and the difference between the amount of energy in the bonds of the reactants and the amount of energy contained within the bonds of the products, well, this is given by this arrow here, and this is the delta H value. In other words, this is what we would call the enthalpy change. And the enthalpy change is the total change in energy for that chemical reaction. And because this arrow points in a downwards direction, this tells us that this particular energy level diagram is for an exothermic reaction. Exothermic. All right then, so let's just recap on that and relate that to the extension question. So the first extension question was, what do you notice about the reactants and the products? Well, as you can see, the amount of energy contained within the bonds of the reactants is greater than the amount of energy contained within the bonds of the products for an exothermic reaction. And you'll know from an endothermic reaction, it's the other way around. The amount of energy contained within the bonds of the products is actually greater than that which is contained within the bonds of the reactants. The next question was, what is the activation energy? So as we've said, activation energy is the energy that you use to break apart the bonds of the reactants, and is measured by this arrow here. Okay, and the arrow points upwards to show that there's energy going in. What does delta H stand for? Well, delta H is the enthalpy change. Up until now in this lesson, you will have called that the total change in energy. So delta H is just the total change in energy between the reactants and the products. And finally, we haven't talked about this yet, what happens when we add a catalyst? Well, I'll show you what happens. The effect of adding a catalyst, it reduces the activation energy. So if you were to redraw this diagram to show this same chemical reaction, but now adding a catalyst, it would look like this. If I do a dotted line to show how that curve would change, okay? And in that instance, the amount of activation energy would be reduced. Okay, so this is the activation energy with a catalyst. There you go.